Hey everybody, this is Miko with Q4 of the weekly contest 282, minimum time to finish the race. So this one I took a long time on. I'm not gonna lie, I have some idea on this one immediately, but not the right one, or not all the right ones. So hit the like button, hit the subscribe button, join me in Discord, chat about this poem, other poems right after the contest. And yeah, and for this particular one, so the thing that I would say, there's a couple of observations. One that I didn't really make until much later on, and having that was instrumental. So one thing that I was noticing, looking at the constraint, is that the number of laps is 1,000. So so immediately I thought that there could be a n square dynamic programming type solution, meaning the number of laps. You can look up, like it's a shortest path in a DAG type thing where from lap I to lap J, you only look at or you only have to look at the best path for that plus the change time or something like that, right? So that's basically the idea behind that thing. And then from that, um, the idea is that we have to construct these best time transitions, right? And for this one, I spent a long time thinking that I have to do something like 10 to the fifth times 1,000, basically saying for each tire, we go, okay, what is this time for doing one lap? What is time to doing two laps? How long to do 3 laps and so forth, right? So you could build that up. And but of course, it's going to take 10 to the fifth times 1,000, which is going to be 10 to the eighth, which is 100 million, which is slow, at least definitely slow in Python, maybe faster in other languages, right? Um, and then once you do that, then everything becomes simple. So I did try that once or first, and I got time limit exceeded because it is 10 to the 8 after all. So then I try to think about different cases, but the first thing, and I did actually thought about this a little bit early on, but I noticed that O sub I is actually has to be at least 2. So I did actually think about maybe that it was 1, but maybe even if it could be 1, I should have been able to make a case study on it, right? Different case analysis. But I don't know. I think one problem that I've been doing lately is that I've been kind of rushing things a little bit, and part of that is just being lazy on certain problems, which I need to not do. But anyway, once I noticed this, then you can kind of do the math on the geometric sequence, right? And once you realize that, then you know that, well, change time will be at most 10 to the fifth. And what that means is that if you keep on doing this ratio thing, like say 20 times, even on 2 to the 20 is already 10 to the 6, right? So that means that with 20 iterations, it's going to be longer than change time, and change time will be smaller than it by a lot. And from that, you can assume that that means that for each number, for each tire, you only need to do at most 20 iterations to get an answer that's reasonable. And yeah, and once you do that, then this is just 10 to the fifth times 20, which is obviously 2 times 10 to the 6, which is slow, but not that slow. And then now you could do the dynamic programming in a very straightforward way, even though there are some optimizations that you can do, particularly if you're in Python. So yeah, so that's basically a lot of words, but let's go over the code real quick. As we said, here's the best. Let me actually annotate this while I talk about it. So best contains the best way to, the best meaning shortest time to do I laps, right? So that means that best sub I will be contain the best way to do I laps. And the way that we did it is just literally brute force. We start with I is equal to 1, then we do the math on a lot of these. Yeah, basically. Oh, how did that happen? What is this? Did I delete something by accident? Maybe I did. What is this? I guess I deleted something by accident. This should be, that's really weird. Sorry, friends, give me a second. Technical difficulties. I mean, I know what I deleted, but it's really weird that it, that's awkward because it's a virtual contest. So it should be something like this, though. I hope that I didn't. Yeah. So while I is your number of laps, and also I think this current is less than 2 times change time or something like that, right? So yeah. So basically, the idea here is that if current goes way above change time, then you should just change time anyway. So that's basically the idea behind this loop, and it updates the best of I for each of these I, which we always said it's going to contain the shortest path of X laps, right? And then here, this is just an n square thing. Hopefully, you've seen it before, but it's just like I said, shortest path in a DAG. It just goes from for I. Look at all the previous J's. This is going to be n square. So let me actually write the context really correctly. Like I said, so this happens as you can see, current doubles every time at least. So that means that this only goes about 20 cycles, and that means that this is roughly 20 times n. Say, okay, let's just say u log u times n, where u is less 10 to the fifth. So that means that this is where this means that u is less than 20, right? So that means so that's basically the time here. For here, this is going to be O of n squared. Though there is an optimization that I didn't make, which is that noticing that because we only keep track of the best 20 up to 20 laps, the inner loop only has to go back 20 spaces or so, right? So in that case, then you drop it from n squared to O of 20 times n, but that's also let me just write out, can be reduced to O of log n log u. So then of course in this case the entire problem is going to be n log u, and that's the time complexity. For space, this is O of n, this is O of n. You can change this a little bit, but still, and you can also reduce both of these to O of log u if you really want to, because then here you just only look at the last 20 elements, almost like if you have Fibonacci looking only at the last 2 numbers. Here you look at the last 20 numbers, for example. Not necessary, but possible. So yeah, so in the optimal case, then you would have O of n log u time and O of log u space. Yeah, that's all I have for this one. Let me know what you think. I'm gonna make this slightly smaller so you can see everything in one thingy. And yeah, cool. You could watch me solve a live in contest next. Like I said, I spent a long time fixing or doing the wrong thing. So fast forward to be like, anyway, see you. Fine. What a silly mistake though. Yikes. I mean, that's such an easy problem, or not easy, but obvious. Okay, let's focus live. Focus. No tilt. Okay. Okay, so you have tires. What the fun? Okay, so first lap in 3 seconds, second lap in 6 seconds. Okay. I guess I get it, but it's just a whatchamacallit, geometric sequence or whatever. Okay. Huh. Minimum time, eh? So you have tires. I've tire can. What does tires mean? I don't know that I understand. Okay. Oh, so it's any set of tires, right? That's not how tires work. You don't have one tire, but okay. Maybe I'm confused though. Okay, so start with 0, finish the lap in 2 seconds. Contains the, okay, 6. Change tires to the new tire 0 for 5 seconds. Just change times 5, okay. Okay. That seems okay. Start with 1. Continue with tire 1. Let's change time to 6. This reminds me of I don't know, maybe not. Number of laps is only 1,000. Can I DP this? I guess I could DP it, right? What is the DP? What is N? N is 10 to the 5th. Is it DP or is it greedy? I think that's what I'm trying to figure out. Cause is it DP or is it greedy? For each lap, so 1,000 times 10 to the 5th is going to be a little bit higher if we do it that way for DP, but feels like it should be greedy, but because you only really care about 2 tires, right? 2 sets of tires, so the N doesn't even matter, right? Because the 2 set of tires that you care about is one that you use for in general case, and then one at most the second set of tire where you only care about one of these. So I guess it could be DP, but with 2 thingies. Is that right? Yeah, I feel like there's like a case analysis here that I'm not really. No, I mean I think I get the case analysis. I think one thing that I've been really bad on lately is just being a little bit lazy about these case analysis, but also because it's hard to be exhaustive. Except for I'm exhausting, but that's besides the point. Okay, am I convinced though? So change plus 1 is 7. Okay. What? How am I convinced that? So for each tire, given a change time, what does that mean, right? That means that given a tire and a change time, we can we figure it out? Because, okay, so we always only care about 2 sets of tire, and then we can, I think we can, for each tire, but that's still 10 to the 5th times 10 to the 9, but for each tire, we can figure out, is that fast? I guess that maybe is fast though. Also, that's 10 to the 8, which is slightly better. I think my math is a little bit wrong, but 10 to the 8 is still pretty slow. Because basically what we want to do is figure out, or I want to do, is figure out what is the maximum, like what is the optimal number of usage for this one, right? Can I do it through math? Like, what's the formula again? F sub I times R sub I times, okay. What is it? Times? Okay. So then that means that tires sub I, and then you take the log of that base, base, what should we call it? Base R to get optimal, right? But that's still like an awkward thing, isn't it? I don't know. I need to YOLO a little bit. What is did people finish this already? I feel like people could have finished this already. Yep, and people did. Wow. Oh, hi Josh, how's it going? That one penalty is sad. Oh, I would have been 3rd or 4th or something, but that one penalty really knocked it down. Okay, but well, I still have to finish this though, so, but that's still a little bit sad. Because basically, you only care about, I wouldn't say 2 tires, but N is a little bit big, isn't it? and n is a little bit big to simulate all the numbers labs. So maybe that, like I said, I guess that's just a log function, but I feel like the rounding error will make it a little bit weird. How do I want to do it? Maybe I could switch to Java or something and do it in 10 to the 8. That'd be fast. Because after that, after all the simulations, then after the simulation, it's just like taking best of two things, right? Maybe? Is it two things? Can I do better than that? Maybe I can do better. Maybe I'm wrong. But then that's dp on the number of laps, which is n squared on the number of laps, basically. The n is very weird. If this was 10 to the 4th, this would be a lot. Like, I'm a little bit more convinced. But let's say it's this. That's basically what I want to do is have a. I think I have an idea, but 10 to the 8 seems a little tight. What's 10 to the 8? Well, it's like 100 mil. 100 mil seems tight. Because I'm missing something obvious. Can I solve this in a better way? In the sense that, can I early terminate? Is it easy to early terminate? Okay, maybe I could figure. This is so awkward. Maybe I could sort it first in a weird way. How do I want to sort it? Is there a way to sort it such that we can early terminate always? That's not really. Maybe. Yeah, this one's weird. Well, I mean, a good amount of people solved it, though. Of course, doing a virtual contest is a little bit spoilery. I mean, I have an idea. So the idea that I have is that if we simulate all 10 to the 5th tire for a number of laps, it takes 10 to the 8th, and then we can just do a dp on the number of laps. It's just which I'm calling like minimum sum something, but like shortest path in a DAG or something like that. But that takes 10 to the 8 to pre-process in a good way. Unless I could do the math in a good way. Missing like one observation maybe. So that would be very trivial, but not fast enough. Well, I guess if the current one, no. If the current one is bigger than, but that's still not like a good proof. But if the current thing is growing faster than the previous thing, no, because in theory you could have a higher constant but lower exponential factor or whatever it's called. multiplicative factor. So we can't really terminate that way. I feel like that's close, but maybe not. Is there anything I can do? do 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 do. If this was 10 to the 4th, I could solve it. I don't even know if this is fast enough in Java 10 to the 8. Because there's very low constant for this, though. And then someone got it in 5 minutes. A lot of people got it very quickly, actually. Oh, Josh, congrats. But I'm already behind on that. Can I use heap to do it lab by lab? I guess so. Like the smallest element. Is that fast enough? So 1,000, right? Basically, if you basically if you see the same number twice, then you're good. But how do I prove that that doesn't take all of 10 to the 5th every time? Right? Can it change every time? I guess so. Because we just want the min every time. So we sort it by the min. So the first thing is going to be thing, and then you times it by number, and you times the tire by each number. Because it's basically the thing that I'm thinking of, in a way, is like the what they call complex whole type thing, where you're trying to get the min of the lower thing. But I'm not really seeing I'm not seeing that it is a complexity safe. I don't know. I can't prove this math. I'm gonna YOLO it a little bit, maybe, just because I can't prove it. Is that what I want to do? I don't know. Let's see. So we want to sort by just the first number, I suppose. Doesn't really matter for the next one, right? So then right? So maybe I. So for 1 and this. I don't know. So we have something like this. So you want to put in the x. No. What we want is x. I guess x doesn't really matter after the first one. So something like this, right? And then we do something like Yeah, but even just calling. Okay, fine. Let's do it this way then. Maybe, I don't know if this is good. And then we do. Okay, so while the second number. Someone like this? I really don't know about this complexity, to be honest. And then. Oh. And now the top one should be the lowest one. So then, okay. Times number of labs plus 1 maybe. Okay, and then maybe you have something like. I have to do more bookkeeping. Even if this works, I feel like I'm not doing enough bookkeeping on this one. And then after this is DP, but I'm not convinced both on implementation and also complexity. The implementation is just wrong actually, but the complexity I'm still not super sold on it. Basically, we wanted a sort of running man, and heap would be a good way of doing it, but also I'm just not. I don't know. This is very awkward. Let me think about this for a second. Maybe I want an additional thing. This is one iteration. Maybe something like this actually. Instead. I think I'm off by 1 here, but nonetheless. Up the first iteration, if this is not. Okay, maybe this is okay. I don't know if this is okay. Yeah, there's so many issues wrong with this one bit. Okay, I also forgot to do. Yeah, I hate Python heap syntax, actually. That's like the one thing that I complain a lot about. But they're not cooking again? I guess not. Oh, maybe this is this actually. Okay, this is not good. So for 2 is 2. What am I doing wrong? Right. That's, ooh, whoops. Okay, that looks okay. Why am I doing? Why is this just? Oh, wait, no. I mean, the heap looks okay after each one. Though maybe not. I only have two. Oh, I didn't pop. Though I don't know why I have this infinite number though. Oh my. Okay. So that is also wrong, but I think maybe this actually. Okay. So still wrong. It should be 2 and 3. What is going on here? This is very awkward actually. Oh, I reused I and that's why it's confusing. Okay, well, silly Larry. Let's just do L then. Yeah, that's why stuff looks weird. Okay, so this is kind of good, but not really because I'm not. Something's a little bit off. Let's see. Oh, in this case, this is L now, not I. Okay. So now, I mean, I don't know if this is going to be fast enough. That's my number one issue. But at least this gives us the DP to solve, right? And maybe we could figure out how to optimize after we get a TLE. But okay. So now this gives us the best path. So what's it called? Right, something like that. And then DP sub 0, 0, 0. Okay, yeah, that's maybe right. Then dp of I is equal to min of dp of j, well, dp of I or dp of j plus best of j minus I, something like this, or I minus j. Or something like this. I think this should be correct. Maybe, maybe not, apparently. Oh, I forgot to add the change price. Okay, so it's still wrong, but off by 1, which is kind of maybe still sketched out. Why is that? I was hoping this was right, but then maybe time limit issue, but I could be wrong. Let's see. So it takes so the best is 2, and then 4. What's 4? 4 is, well, how do I have 6? 2 times 6. 3 is 18, and then 54. Okay, and here it will be 3 times 4 is 12 after 1. Yeah, okay. So why did I get 22 instead of 21? 2 seconds, 6, 6. Where did the new tire for 5 seconds? Okay. So, and I have 22. How do I get 22? 18 plus, what's that? 3 plus 1 plus 1? What? What am I doing well? Feels mostly right. Maybe my DP is wrong. Not even gonna be. Okay. How do you even get 22? Okay, Okay, 7, 8. Okay, so 1 is 7 is a little bit weird. Did I mess up something? That's definitely wrong. So 0, okay, 0 doesn't do anything, that's fine. 1 is 7, huh? Oh, changed, oh, because we have to minus the, so you start, but we have the change time. That means that we're off by a lot if we want to minus the change time. So yeah, okay, well, let's see. If j is greater than 0, we do this. Else, then we just do this, right? Yep, okay. That's what I thought, but also this is wrong. Unless I misunderstood the problem. That would be funny if all this time I misunderstood the problem. Why does this 17 do? So 2, 1, 2, what is it, 4? 3 is 13 because why? 5 plus 5, no. 6 plus 5 is 11 plus 2. Okay, maybe that's right. And then 17 is 6 plus 6 plus 5 is 17. Okay, maybe that's right, but why is this one? Or 21. Why is this 21 then? Do 6 plus. Oh, I messed up, didn't I? Because okay, I get it, but that's not that hard. Because this is prefix sum almost of this thing, so I just have to update this because it took 6 seconds for the second lap, not a total 6 seconds. Okay. I mean, I just have to add more things, I guess. It's not a big deal, but it's still a little bit annoying. Don't even know if this sorting makes sense anymore, though. Maybe it's fine. How do I want to do it? Can I represent this a little bit better way? Oh no. So the previous x. This is going to be very awkward very quickly though. I don't. What is that recurrence? Huh. Oh. So it's 2 and then 8. Why am I so bad at math? Okay. Let's see. So it's x, and then it's x plus x times y, and then it's x plus. Okay, fine. I mean, I guess there's no other easy way to do it. So just do this. So the okay, so previous is this, and then now it's just previous plus x times y to the c. Yeah, maybe this is it. Let's see. Why is this taking so long? Maybe I have some weird thing. Why does that time limit though? Oh, because this is now the 4th element. Or the 5th element, really. Alright, so now we have it, the right answer, but I don't know if this is going to be timeout. I actually do expect it to time out, but I don't know how to fix it, so let's give it a YOLO for now. Okay. And then how do we want to fix it when it times out? Oh no. Yeah, okay. So I kind of expected this, to be honest, but at least it'll give us something to play with. Let's see. Is it just one case? Yeah, okay. All these are just ones. Okay, so the dupes, and we can get rid of that. I think that I think we have to figure out a way to start removing stuff from here. I think that would help. Like, I mean, you have these curves, and then you remove. What a hard problem, huh? So then, how do I want to do this in a good way? Let me think it through a little bit. How much time do I have left? Let's see. Okay, I still have about an hour left, so that's okay. Okay. So then now we start with a starting point where with all these curves. Is there a smarter way to do this? How does this fit anyway? I guess you can just always do change time. Okay. So I think that's one thing that maybe I missed a little bit. Is that I don't have to simulate the number of laps. We just have to simulate the change time. And from that, we know that there are two cases, right? If change time is, or with R sub I, R sub I is, so R sub I was actually thinking too much about R sub I case is equal to 2, but that doesn't seem to apply here, right? So then, okay, I think I have an idea now, but I think I am a little bit dumb on this one. I also just want to curious whether this will give me, did it time out before? Because I don't, sometimes it works for one case, right? Maybe it still times out, but that's fine. Okay, so now that we know R sub I is 2, which I missed, then we can do it with respect to change time. Because then now instead of, okay, I get it. Because instead of each one having 1,000 laps, we can have, what's it, like 20? Yeah, 20 is a million, so it'll be like less than that. So then it's just 20. Oh man, now I feel a little bit dumb. Okay. Okay, let's try this again then, shall we? Okay. So best is equal to this thing, right? I feel a little bit dumb now though, but I guess it is what it is. So for F and R in tires, let's see, because if it goes over change time, what does that mean, right? If it goes over change time, oh geez, my toe is bleeding. If it goes over change time, that means that you just use the change. Now it's over change time plus the initial thing, right? Something like that. Let's see. What do I mean? The initial thing being F sub I. So maybe just change time times 2 just for laziness. Maybe I'm right on this one. Maybe I'm not. But okay. So I is equal to say 0, 1 maybe. We start with F, okay. Oh jeez, my toe is bleeding. I kicked it over something. Okay. Something like that maybe. And then we want current is equal to F times R times I, or 2 the I, whoops. Okay, we want this here. I think the I is off by 1 actually, so Something like this. Okay. Okay, let's see if this at least gives us the right answer. Man, my toe hurts now. What a dummy. Oh, I forgot to infinity. Okay, that is, oh, I mean, this is right for this one, this is right for this one. This is taking 1.6 seconds, which is not great. I don't know if it's the right answer, to be honest, but, and I have to not print this thing. Maybe it'll be faster if I don't print this thing, but maybe that is good enough. Let's see. Oops. I think even if, I was worried about all sub I is equal to 1, but I think even in that case, I should have just special cased it. I was thinking too much in my head a little bit. We'll see if this times out still though, because it seems still. Oh, okay, what did I do? Oh, okay, that's just dumb. But okay. Okay, Larry. You are being silly today. But you know, that's what, you know, okay, is that the right answer though? They don't tell me the right answer, they just let me know that. And okay, what is the right answer for this one? Oh, well, number lapse is 1, then it's just 1, right? So I think this is right for that answer anyway. Let's see. Come on, don't time limit exceed it. Oh no, okay. Okay, so we have to still optimize a little bit more, it seems like. Or it's a Python thing and I'm going to hate someone again. But that's, yeah. I mean, this one's fast enough-ish, 2.917. So can I make this loop a little bit tighter? Well, at the very least, we can do something like if, because that probably gets executed a lot. Might do the same here, though that's only 1 million operations at most, I don't know. Did I mess that up? Oops. Okay, wow, that's even slower. So maybe I messed up. Can I do this in a better way? Oh, now it's a second faster, even though I did nothing. But do I need to change this? Maybe. I don't know. This is so much guesswork. That's what I hate about it, right? Like it's not even. Like I'm okay with TLE, but I just don't know if this is even going to be enough, right? That is the problem. Let's see. So now, before it was like 2.1 seconds, something like that. Okay, that's even slower, but I don't know if this is going to be faster if I do it. Do I need like a silly optimization? I don't know. Let's give it submit because I don't. It's so hard to guess, right? Like I'm literally just guessing because this should be fast enough-ish, unless I'm really missing some obvious things. This is just silly, right? Like the optimizations that I have to do. I almost bet you that in Java this is good enough, but I don't know, because this is just like 20 loops, 20 times 10 to the 5th, and this one is just DP, which is 1 million, right? 1,000 square. Hey everybody, yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord. I will see you soon. Stay good, stay healthy, and to good mental health. Bye-bye.